Here we're going to install the voltage regulator. It should say 7805 on the component. This voltage regulator works in conjunction with our 9-volt battery or USB power supply. I believe that 9-volt batteries, as they drain, will put off less voltage. This will regulate that voltage in order to provide a stable 5 volts to our LED circuit. So first of all, we'll locate the 7805 slot, and it goes right here, like so, with the metal facing out towards the USB connector or the power supply. So it must be installed in that direction with the metal towards the outside of the board. This would be step 6I. We're going to install this. So you should see writing, it says 7805 toward the bottom of the control board. So all the pictures in the manual are pointing that this is the install for the entire control board, even the one on the front. So we're going to go with this. So it's pointing out this direction. I'm going to install my heat sink. Not necessarily for a heat sink, but this is going to give me a nice firm hold on this component when I flip it over. So I'm going to flip it over. What you want to make sure of is these heat sinks, if you're passing a lot of current through them, that they actually sell little radiators that go on here. We don't really want the metal touching anything on here, so I'm going to pull it down just a little bit, probably not as close as they put it. I'm going to leave it stick up just a little bit. So I'm going to add my heat sink, and then I'm going to solder my leads. I think I'll do it like this, so get a little better view. Now remember that these connections are very close. If you apply too much solder on these 3 connections right here, then you will run together and have to desolder it. So you want to make sure that you do not get solder on any of the other connections on this board. Hopefully I won't do that. So let's see. So I'm going to tin my soldering iron. I'm going to get some heat transfer, and I'm going to apply some. Yeah, that angle's not working out for me. Let's try the other way. Try this way. Maybe even bend these back just a little bit, and we'll see if we can apply some heat now. All right. Clean my tip. Apply a little solder. And we'll try this on this other board. There. It finally got hot enough to run down and seat on the board. Remember, I can trim off the excess. You want to take your time on this and not try to go too fast, because the heat will destroy the component. I'm looking at this joint on the other side, and it looks to me like that could be a cold joint right there. So I'm going to apply just a little bit of heat and see if I can't do a little bit better job of melting that joint. There. So I think that might have made connection. Clean my tip, and we'll shoot for the last joint. I think I'm going to try this one from the outside, try to level up this board a little bit. try this outside joint. Apply a little solder. We're going to some heat on there. Apply some more solder. Hopefully it bonded right there. Apply a little bit more heat. So I'm going to inspect this, looking for a crack or cold solder joint. Looks to me like it bonded fairly well. And so if you'll grab your heatsink at this point, you'll notice it has gotten slightly warm. That's absorbing that heat that would typically go into the component. The component is not as hot as the heatsink. And so I can simply take my component and bend back into a nice level position. You don't want to bend it back so far it's touching this USB portion right here. It doesn't get inserted quite as much. It looks to me like if I tried really hard I could bend that over, so you want to watch that. So I'm going to go ahead, we're going to trim these off. Make sure your safety glasses are on. These actually went flying, so we've applied that. Next, we are going to install the transistor. I've already installed one of them here. Now this acts as a switch for our LEDs because our LEDs are going to alternate between red and yellow. The capacitors are controlling the time. There is a video on my YouTube channel that explains this, of how a astable multi-vibrator circuit works. So there's a video on there that you can go through and see once you've completed all of this to see how this works. And I'll explain it during the testing phase a little bit, maybe more in layman's terms than the video. So now on to installing the transistor. You have 3 parts to this transistor. If we look, here we'll see we have a base, a collector, and an emitter. Basically, voltage, depending on the type of transistor, is applied to the base, which either will allow this to conduct electricity from the emitter to collector or vice versa. When that voltage is taken away, this no longer conducts electricity. So it acts just like a relay with no moving parts. Here we have our schematic symbols. See those. So we're going to install our component. Notice there is a diagram called Q1 and Q2. I've already installed Q2. I'm going to insert this, and the flat side of the picture on the board needs to match the flat side of the component. Now these will have to be bent slightly. So we're going to try to see if we can get that in there. Now, I've already installed one, so I'm simply going to push it down. And I'm looking to make sure that it is about the same height as the other one. And as I push it down, you'll see it firms up, and that's good. We're going to apply our heat sink across the top to absorb some of this heat that's going to be coming off this. Then we're going to flip it over and apply some solder. Apply a little heat to the component to get everything heated up, and then feed in just a little bit of solder until it runs. It's not cooperating with me right now. There it goes. And so it finally got enough heat to actually seal to the board. We'll repeat this, just a little bit of heat, a bit more solder, and we saw that it ran down the the stem on the board, but that looks to me like it might be a cold joint, so I'm going to apply just a little bit more heat to that and make sure that it bonded fully. Doesn't take a lot of solder for these. We have the outside one. Clean my tip a little bit. See if I can't hit that outside. Once again, if you apply too much solder, you do not want this running over to somewhere else. You'll be a short on the board. So I'm going to apply just a little bit of solder. So we can get some heat transfer here for a few seconds and then feed in the rest. And if we apply enough heat, it should run down. I'm going to take a quick inspection of that to make sure that it did seal. To me, like it bonded pretty good to the board. Remove the heat sink, trim off the wires. And so now I have completed soldering the control board, and it's time for testing, which we will do in the next video. So let's take a look at this board. So we have a nice big picture. Here's my 9-volt battery. We'll zoom in just a little bit. And so that's what your assembled board should look like. Now, there's one step in here that you don't have to do it now, but you do have to install the battery holder after testing and assembly. And that's listed in some further steps. I'm just simply going to show you where that goes. It's really no solder involved in that. Simply going to go on your board like so. You should have 2 small screws. I'm not going to install this now, but you have 2 small screws. Will actually insert into your battery holder for your 9-volt battery. Be careful not to drop the screws and lose them. They're pretty small. So we have our screw holder. There are 2 of them. And we install that onto our board. So I'm not having much luck at this time. And we simply, this will be the last step after testing, so we can screw that down. You also have another screw that goes right here.